Hello everyone, I'm Gagana V from Sri Venkateswara College of Engineering. Today, I'm here to explain about a topic related to converting NFA to DFA, which is a concept which comes under TOC. So, what is NFA? NFA stands for non-deterministic finite automata, can have multiple transactions for a given input symbol from a single state, can have epsilon transaction without consuming any input symbol. So then, what is DFA? First, you basically need to understand the terms to dive further into the concept. What is DFA? DFA stands for Deterministic Finite Automata, has exactly one transition for each input symbol for every state. No epsilon transaction. So epsilon transaction basically stands for transaction without consuming any input symbol, which is possible in NFA, but when it comes to DFA, it is not possible. Then, the conversion process. The core idea behind converting an NFA to DFA is to stimulate the NFA's behavior deterministically. We do this by grouping multiple NFA states into a single DFA state. Here are the steps involved. First, you're going to start with the stat state. The initial state of DFA is the set of all NFA states reachable from NFA stats stating using epsilon transaction. First, the initial, what we do is the initial state of DFA, and then it is all set to NFA for the reachable state for NFA stat. And then we start with the transition function. For each DFA state, for each input symbol, determine the set of NFA state reachable from the current set of NFA states using the input symbol and any subsequent epsilon transactions. This new set of NFA states becomes the next DFA state. Okay, what is the final? The final state, a DFA state is final state if it contains at least one final state from NFA. So here you can see this is the final state, and then this is the this is the initial state, and this is the final state. The state which encloses another circle within itself indicates that it is a final state, and then an arrow pointing towards this one indicates that it is an initial state. An arrow which contains like a self loop, it indicates that it is self looped with certain number. Now, to convert from DFA to NFA, we have a in-depth study. So first we are going to start with the stat state. The initial state of DFA is Q0, Q1. Since there's an epsilon transaction from Q0 and Q1, the transition function from Q0, Q1 on input A's reachable state are Q3, Q2 and Q3. On input B's reachable states are Q1 DFA states. From Q2 and Q3, on input A, reachable states are empty set, a new DFA state. On input B, reachable states are Q3 DFA state. From Q1, on input A, reachable states are empty set. On input B, reachable states are Q1 itself. From the final state of on input A, reachable states are empty. On input B, reachable states are empty. Final state Q2 or Q3 is a final state because it contains the final state Q3 from the NFA. The resulting DFA would look like this. So you're able to see this is the Q0, this is Q1, this is Q2, this is Q3, and this is all the connections between them. Yeah. Now, here comes the key point which needs to be remembered. The number of states in DFA can be exponentially in the number of states in the NFA. There are algorithms like the subset construction algorithm that can systematically construct the DFA. While the conversion process might seem complex, it is fundamental concept in automata theory and has practical applications in areas like compiler design and regular expression matching. By following these steps and understanding the underlying principle, you can effectively convert any NFA into its equivalent CFA. Hope you understood the concept. Just for some brief introduction, I would skip to briefing of the concepts.